This video gonna prove the following fact. For any given integer n, sigma of n factorial divided by n factorial will always be at least as large as the sum of the reciprocal of the first n numbers. After all, 1 is the same as 1 over 1. And these are the first n numbers, and I'm summing up their reciprocals. If you like seeing mathematical proofs like this, definitely consider subscribing to my channel. Main reason is this is all we do here. We prove mathematical theorems. If you've been watching my videos, you should know the following, that if you add up 1 over d, where d are all the divisors of n, you get sigma of n over n. But n is any number. That implies that if n happens to be the number n factorial, we're still gonna get, let me just write it the other way. We're gonna get that sigma of n factorial over n factorial is equal to this. Okay. Clearly, 1, 2, all the way up to n are all divisors of n factorial. I didn't say they are all of the divisors. I'm just saying this list, I could have stopped at n minus 1. That list are all divisors of n factorial. But I'm going up to n. By no means am I saying they are all of the divisors of n factorial. Okay, note that there may be more divisors of n. I don't care about that. We know that sigma of n factorial divided by n factorial, which is equal to the summation of the reciprocal of all the divisors of n factorial. That's going to be greater than 1 over 1 plus 1 over 2, or equal to, all the way up to 1 over n. Because these are definitely divisors. There's no question about it. These are all divisors of n factorial. So maybe we should say, oh, I made a mistake. I should say equal. Oh, there may be more. That means I'm not adding the more. That means this side is going to be greater than or equal to. Let's get rid of the more. Let's put back the greater than equal. Let's say this proof is finished. There may be more. Are there more? I couldn't care less, if you must know. Doesn't matter. But let's just look at an example. 6 factorial is 1 times 2 times 3 times 4 times 5 times 6. Clearly, those first 6 integers are divisors of 6 factorial. Absolutely. 1 goes in there. Cancels out the 1. 2 goes in there. Cancels out the 2. And you have 1 times 3 times 4 times 5 times 6. All of these numbers go into it. But you know what? 6 times 5 goes into it. 4 times 2 goes into it. 3 times 5 times 6 goes into it. There are other numbers. 6 times 5 clearly goes into 6 factorial. It goes in, oh, coincidentally, 4 factorial times. That survived, and that happens to be 24. So there are numbers other than 1 through 6. But maybe for some, and there aren't, I don't care, couldn't care less. This, which equals this, is at least this large. Again, even if it was always equal, and I gave a counter example down here, but even if it's always equal, it's not untrue to say it's greater than or equal. 7 is absolutely greater than or equal to 7. Okay, I admit it's probably nicer to prove your theorem if it really is equal, that you say equal instead of greater than equal. But obviously, it's not always equal because I gave the counter example with 6 factorial. Okay, now, just one last comment. If you wanted to say that, yep, sometimes it really can be larger, you can give that you can give that example and show that, hey, it's not equal. It's actually larger. Hey, once again, if you like watching videos like this, subscribe to my channel. Please leave a comment. Click the like button. See you guys in the next video. Thanks for watching to the very end. And don't forget, watch and learn.